All right, we are live. Welcome to the Gunner Technology Livestream, a weekly tech talk for the non-techies and techies alike. I'm your host, Derek Merkins. With me is CEO of Gunner Technology, and with us is a very special guest. We have JT Wallahan from Booz Allen Hamilton. JT, thanks so much for hopping on with us today.
Thank you.
I actually have a Booz Allen Hamilton. This is going way back. This is like, oh my gosh, like 14 years ago now. We had a career day at Wesley in my senior year. And one of the companies that I interviewed with was Booz Allen Hamilton. The only thing I remember from that interview is they asked me how many ping pong balls could fit in a 747 airliner, something like that. So did you have to go through that? Was that one of your interview questions?
You know, I'm pretty happy that they didn't ask me that one. I don't know if I would have gotten the job if they did.
It was a nightmare. I mean, yeah. I remember they just slid across like a pencil and a sheet of paper and we're like, go to town. And it was like, I have no idea what I'm doing.
Yeah, well, the average circumference of a ping pong ball is, yeah.
See, yeah. That's why you got the job. That's why you're
right. There you go. Yeah, I knew the word circumference. Yeah.
Exactly. Well, I guess before we dive into things, before we talk about your book real quick, let's just need to do a little bit of housekeeping on our end. We have our Country Store giveaway. Country Store is a lifestyle brand for stores. You can visit them at countrystore.outfitters.com. Sign up for the Country Store giveaway on our Facebook page. The winner this week is actually from, speaking of Wesleyan, from the Connecticut neck of the woods, Martin S. from Hartford, Connecticut. You've got a Country Store hat heading your way, along with copies of our ebooks. Congrats, Martin. And anyone who didn't win this week can sign up on our Facebook page. And while you're on our Facebook page, answer our question of the week, which this past week was, wait, now I'm blanking on it again. Shoot, I need to pull it up. Oh, this past week was, would you be okay with algorithms determining prison sentences in courts? And overwhelmingly, the answer was no, which is interesting for today's discussion because we'll probably get into a lot of that, the sort of ethical quandaries around algorithms determining stuff like that. But next week's question of the week, next week's topic is going to be AI. So the question of the week next week is, are you afraid of an AI-esque revolution a la Eagle Eye or iRobot? So are you worried about that? An AI takeover of the planet?
I'm not, no.
It's a hard no from JT.
Yeah, hard no. Yeah. Maybe in a couple decades, but in the near term, no.
So like not in our lifetime. We don't really need to worry about it.
Yeah, I would say we're far in the future. I think the people who do serious thought around what an AI takeover would look like, think that a non-robot AI takeover is more likely. So it's more likely that you would have self-replicating computer virus that, accumulates
the infrastructure of the
right. Or, just short circuits the stock market and does something really weird, right? And might not even be malevolent, just unintentionally like optimized to do the wrong thing.
Well, I mean, that's an interesting point too, with especially with the algorithms discussion, is so much of it is human error. Mm-hmm. And that might be actually like not human error is a good lead into your book, but data in general and working with data. Mm-hmm. Let me just pull up your book here real quick. It's called Mastering Large Data Sets with Python. Yep. So tell us a little bit about your book real quick before we sort of dive into the topic du jour.
Sure. So the book is targeted at the new data scientist or data analyst, or someone who's working with data, has familiarity with how to work with data, and it's really giving them a toolkit to scale their abilities up to the size of data that you would deal with in modern enterprise systems. So every organization out there has big data or has desires to do big data work, but not everybody is taught the skills to do that. There are actually really few places where you can go get the skills to do that if you're not learning on the job. And so the goal of this was to provide a concise path to be able to accumulate those skills.
So it's really a hands-on book, a lot of practical application.
A lot of practical application, and it's all geared towards things like parallelization, distributed computing, taking the things you already know. So I'm assuming you can already solve the problems that you want to solve, and just scaling them up. So how can you solve them bigger?
Yeah. I was going to say,
when we start talking about topics like this is, I think like our audience not being technical, can you give like a concrete example of a problem that like big data solves, like an actual, like we all know what big data is and we know what it does, but like I think like
a common example that I like to use is you can think of a person who launches a small app, right? And this developer might have the ability to launch an application, but then when it goes viral and everybody wants to download it, their application is going to crash because it's getting, way too many requests and all that, right? They need a different solution than what they normally would have done, because building an app that can scale is different than just building an application, period. And this book is targeted towards data analysis and data processing more than it is application development. But that's the idea, is that you can take the skills that you have, if you come from a math background or a statistics background or a programming background, and take the skills you're familiar with working with small data sets, and you can bring them to large data sets.
And so to take that a step further also, and again, this is more for our
of course,
non-technical clients. Like what's an example of like a data set that would be worked on? Like what is the actual data? Like maybe it's like traffic light changes. I mean, what's an example of the data sets that you would be working with, and what would you be trying to learn from that data set?
Yeah, so the most common one that folks deal with is web logs. So every web page generates log files that describe the traffic, and you take the traffic data and you mix that with your user database and information you have about your users. And then you learn more about what people want to do with your website, how they're interacting with your applications. And then you use that data to provide better products and services to them. That's the standard case.
And also, you can I guess you could probably glean nefarious uses of your website, as opposed to kind of glean any potential weak spots in your stack, and almost kind of get ahead of attacks if you can recognize patterns in data usage and stuff like that.
Yeah, absolutely.
And as anyone who's interested in checking out JT's book, there is going to be a discount code in the description of the video here. So definitely check that out. We're also going to be doing giveaways on our various social media platforms. So check us out on Twitter, Facebook, Instagram. We're going to be doing a couple of contests to give some copies of JT's awesome book away. And I guess maybe sort of talking about big data and the collection of data and the processing of data is a good point to dive in to our algorithms discussion, because so much of algorithmic behavior is based on the amount of data that you have and the quality of the data that you have. So in terms of a definition of an algorithm, and jump in here and correct me if I'm wrong, but there's a formal definition in terms of like Turing machines and stuff like that, but I don't think we need to get into that nitty-gritty detail. But algorithms, a basic definition of algorithms is a set of instructions that takes a batch of input data and produces a batch of output data, and then utilizes the results to improve the set of rules that it's based on. I don't know if you guys want to add anything to that definition, or JT, do you have any additional info there?
Yeah, I would say the key to understanding algorithm, like the idea of an algorithm, is just that it's a rule that describes a behavior. Mm-hmm. And if you're non-technical, that's probably all that you need to know.
And so we're really talking about processes here,
Yeah.
And when people talk about stuff like automation and replacing jobs with code and with
mm-hmm.
program, you're talking about rules that are being followed that can be explicitly represented in a code-based form.
Yeah, algorithms are instructions on how to do a task. So the idea about is if I can replace your job with just instructions about how to do the job, right? So
Yeah.
you think of like a train, right? Just drive from this stop to this stop, or a plane. We can land planes more or less automatically now, just with very complicated algorithms. So
if we're talking about algorithms in that sense, as a set of rules or instructions that produce behavior, it seems like there's multiple places that algorithms can fail, or at least fall short of the goal. So you can fail on the side of the input data that you're working with. If the data that you're working with isn't accurate or isn't representative, that could be a point of failure. It could fail in the behavioral side of things. If the output that you're expecting the algorithm to produce isn't actually the output that you necessarily want, or that's necessarily in the best interest of the parties involved in the algorithmic behavior, that might be another point of failure. And an interesting one too that's sort of come up recently with the rise of neural networks and sort of black box algorithmic behavior is the actual rules themselves are sometimes innocuous to the developers of the algorithms, and they're not necessarily entirely sure about what's going on. So it seems like it might be good to sort of talk through each point of failure, because it seems like algorithms can fail in multiple different ways. So I guess maybe a good place to start would be the input behavior. And one of the major contentions with the input data, rather, is whether the data itself is representative of, especially in terms of algorithms that work with populations, representative of the general population. So I'm thinking here of Amazon had a major snafu a while ago with a hiring algorithm that it developed that I guess inadvertently or unexpectedly or not to Amazon's liking produced a hiring algorithm that I think 80 to 85% of the candidates that were selected by the algorithm itself were male. So it seems like the data itself needs to be sussed out in such a way that it is fair to all parties involved, right?
Yeah, that's absolutely true. I think one of the cases that's really obvious to folks is these AI conversation systems, right? So your Siris, your Alexas, your Google Homes, the algorithms that are used to do the voice detection, so the part of the system that takes your voice and translates it to what the computer recognizes as words under the hood, are trained primarily on the voices of white men. So these systems are notoriously bad at gauging women's voices, or people of other ethnicities, or I have friends who are foreigners and they've got accents, and they can't hardly use these systems, right? Because they're trained on native English speakers.
And so that is a solvable problem, right? That is something that it's really just a matter of understanding that problem exists.
Right. It's understanding the problem exists and then applying the effort to get the data. But getting the data is non-trivial. It takes a lot of time. You got to sit these people down, record their voices, do things like that. But it's a solvable problem for sure.
And that is I think, in my experience, the biggest problem is getting the data. And that was Amazon's quote unquote problem, was the data that they were working with was historical data. Like they basically backed into it. They said, okay, who are our really good employees? Who are our best employees? And what traits do those employees exhibit? Well, because women are behind men in the marketplace, or in the workplace, they're catching up, as we all know. Like most of Amazon's examples of good employees were men, just because there was a higher sampling of men on Amazon's payroll. So getting a hold of that data is tricky, because you don't want to force. Once you start changing the data, then you are actually you're introducing another human element to try to kind of make up for a potential lack or skewing of the existing data that you have.
Yeah. And there's also the problem of correlation with these things, right? So you try to do the right thing, you try to remove gender from your algorithm, but your algorithm isn't stupid. It picks up on the fact that more men do this than that, and it uses that variable as a proxy, and it learns the problems of your data even when you're trying to get it to not.
And that's an interesting point too, in terms of. Sorry, go ahead, Cody.
No, I would say a good example there, to put it a concrete example for our listeners. Like if you were trying to kind of use an algorithm to create an all-star basketball program, it would skew toward men because height is a factor into how good someone might be at basketball. So that would skew toward men because men typically tend to be taller than women. So it wouldn't default to say choose men over women, but because it's putting such a premium on height, it's going to select more men than women, and that's what JT kind of means by a proxy for gender. Height becomes a proxy for gender.
And I think also what's really interesting there is, I mean, it sort of leads to the output and result side of things in terms of what you're expecting the algorithm to produce. Because I think what Amazon saw when they input their data set and they said, here are the training rules, look at these key performance metrics of our employees and produce a predictor for employee performance that will help us in hiring. And it overwhelmingly produced men based on a lot of the factors that Cody talked about, which is, seniority of men in the Amazon's workforce. So the interesting thing about algorithmic behavior is that you can sort of tailor the algorithm to produce the results that you're expecting or that you're desiring. And a lot of the sort of ethical conundrums around algorithms sort of come from, instead of left to right, from inputs to outputs, it comes from outputs to inputs. So there's actually a really interesting article in CIO magazine that had this quote: an algorithm that maximizes accuracy regardless of statistical parity embodies the moral principle that fairness is accuracy in classification. An algorithm that has been adjusted to achieve statistical parity embodies a normative judgment that some loss of accuracy is needed to avoid further subordination of historically disadvantaged groups. So it seems like the algorithmic discussion automatically sort of gets into the weeds of the larger ethical discussion about, I guess, sort of equality of outcome versus equality of opportunity, or, some serious normative ethical debates. And JT, how does that sort of influence the algorithms you develop based on the data sets that you have?
That's a good question. I would say that one of the things that I try to do is I try to emphasize algorithms that make suggestions rather than algorithms that make decisions. So you can set up an algorithm such that it finds you its favorite candidate, right? What the candidate it thinks might be the best candidate if you're Amazon. Or you could say, let's set this algorithm up so that it recommends, the top 10, and then we'll have a human pick. And including a human in that process allows you to counteract some of these things. It also can prevent you from over optimizing a system that's just not that precise. A lot of times we'll get false confidence in the results of our algorithms just based on the fact that a computer did it. Just because a computer does something doesn't always mean that it's, done well.
Yeah. I mean, there certainly is sort of like a dehumanizing angle to offloading all human decisions to algorithmic processes. But Cody, would you say that the point of machine learning and algorithmic behavior is to remove as much as possible the human element from major decisions where those decisions could be influenced by sort of the whims of human behavior? I'm thinking maybe specifically here about, we talked, I think 2 episodes ago, about and this was what the question of the week was about sentencing behavior, where judges deliver much harsher sentences right before lunch, and then after they've eaten lunch, the sentences are much more lenient. Is that so? How do you balance, Cody, the role of human behavior and keeping humans involved versus removing human behavior and keeping humans from being involved?
Yeah, well, and again, this is where I think the ethical considerations comes into play here. Like, again, use my basketball team example because it's certainly less inflammatory than Amazon hiring. Let's use that for example. So let's say there's a big stink about this basketball algorithm, and there's an outcry. Oh, it's picking all male teams. There's no female representation. This algorithm is biased against women. Okay.
And Spud Webb and Muggsy Bogues are up.
So they introduce a human element where it's going to recommend the top 10 players, and then then the machine will pick 4 of them, and then a human will pick another one, and there has to be at least one female per team to remove that bias, that exclusion against women. Well, what happens if those teams where you inject that human bias, that to remove that ethical consideration of excluding women, what happens if those teams are objectively worse? They objectively perform worse than the strict machine-driven team selection. What do we do then? Do we say, well, it's still not fair to women, so we're going to make our team worse just to be fair? Or do we say, okay, well, we tried having the human element to keep it fair, it didn't perform as well, so now we'll go back to a strict machine selection algorithm kind of thing? That's where I really think that it's a conundrum, and for me, believing in like pure meritocracy, I say you go back to the algorithm, because at a basketball team, the only thing that matters is how many wins you have versus how many losses you have. And I know not everything's that cut and dry.
Yeah, I was going to say that's sort of the crux of the issue, is how you define the success metrics of the basketball team itself, whether it's wins or losses, or whether it's other maybe external factors, team building, cohesiveness of the team, long-term success of the individuals, what sort of impact it has on the population at large. Maybe the team itself is less successful, but having a female player on the team produces net positive results in the global population when, certain girls or young women see an icon on the team that they can look up to, and then later generations actually, with females on the team, perform better. It's tough because you have to sort of, a lot of it is you don't know until you've tried it. And it takes a long time for the results to come in. It
takes a long time. And so you're exactly right. So that's why I'm trying to hold the success result or the success metrics constant. So one of the ones that Facebook loves.
Well, isn't that the problem with algorithms, is that you have to have some sort of constant success metric. And so all of these thorny, maybe unquantifiable or less easily quantifiable metrics aren't easily implemented into an algorithmic process, if that makes sense.
Actually, I think the main problem here, I think the main problem here is, how do you combine the two in an ethical way? Because like if you put an algorithm, if you put a machine in charge of saying we need to get to carbon neutral by 2023, it would just kill all humans. Like, that's what it would do. You know what I mean? Like, given that opportunity, it would just, okay, great, let's do it. That's my success metric. Here's how I'm going to do it. Done. So
we need Shia LaBeouf to save us from our AI overload.
Like, obviously that's not okay. But if your success metric on a basketball team, if we're saying our success metric is wins and losses, is it okay for a machine just to stack the team with all guys and never pick a woman?
Well, I mean, that's where the rubber meets the road, right? Because there was another really interesting sort of algorithmic difficult situation. So there's Google developed an AI that was integrated into
a search algorithm.
You might have heard of it. They just built a website for it. They built an algorithm that would predict the results of doctor's visits, basically. So they could predict with like 95% accuracy. Is something ridiculous. both what the result of the visit would be and what the long-term diagnosis would be, and sort of the long-term prospects for the patient. And the difficulty came in the sort of secondary realization that the actual results produced, it was sort of a self-fulfilling prophecy. So the Google algorithm says, you know, you only have like a 5% chance of living past 6 months. And in those cases, the patient would die within 6 months more often than patients who hadn't received such a negative diagnosis. So, I mean, JT, how do you, like, with algorithms that have real world effects on people, on actual, you know, human lives, we're not sort of talking about, you know, just sort of like abstract algorithms that might be crunching numbers or, you know, producing a bunch of data or predictions, or like, you know, like we're not talking about like sports betting algorithms here. We're talking about algorithms that might have a deleterious effect on the longevity of a human life. How do you sort of make sure that those algorithms are not necessarily accurate, but not having a profoundly negative effect on people?
Sure.
Long term.
I think the key here would be to separate the algorithm from the individual's interface with the healthcare system, right? Mm-hmm. They might be able to, you know, go to a website and enter the values necessary to get some form of diagnosis, but instead of, you know, that diagnosis being, you know, you have 6 months to live or what have you, right? Maybe that diagnosis is framed in a different way, or maybe it's more open-ended. There are lots of, just because an algorithm says one thing doesn't mean that we need to tell the person what the algorithm is saying. There's, especially if we believe that the probability that they could outlive their diagnosis should be weighted more, and we're more interested in those cases than we are in cases where they don't. You know, another thing we want to make sure is that we aren't, you know, that 5% of the time that we're wrong with these diagnoses, that they're not really serious mistakes. Because if that 5% of mistakes is a really subset of really, really serious mistakes, you know, that's going to cause us a lot of problems. And we might rather be right that 5% of the time and wrong the rest of the 95%. Depending on how serious it is. Yeah.
And the interesting thing too there is that the trouble with algorithms and procedural behavior is that it's so disconnected and abstract. And it's not even necessarily telling the patient that they have a 5% chance of living past 6 months, but it also, this is one of the, it's the British healthcare system implemented sort of algorithmic behavior in terms of like distributing funds, basically, like who to spend the most money on because they have the best chance of survival. So you're actually making dollars and cents decisions there based on, you know, so has a X% chance of living, so has a Y% chance of living, and maybe that's the right way to do it. It just seems that if you turn that kind of decision making over to a non-human process, you might be losing something by doing that.
Yeah, I would imagine that the listeners who had the problem with your automatic judging system would also have a problem with a system like this, right? Because you've effectively got an algorithm determining, you know, who gets money towards their healthcare and who doesn't. But in the UK, they're a lot more comfortable with rules around who gets what money for healthcare than we are in the US. So that might be a value that they're okay with and we're not, and it might be a cultural thing.
I will say, this is a quote from that same CIO article. It said, earlier this month, the Pew Foundation reported that 85% of the public would support regulation. I don't actually know what this means, to restrict the use of AI by businesses and organizations. So, I mean, how do you deal with the fact that most folks don't want this? they don't want algorithms running their lives. Like, what's the solution? Is it regulation? Is it?
you're never going to hear me say it's regulation unless we're just talking about like across the board big brother subjugation. That's the only regulation is either 100% or
It
like
is all
0%.
in or he's all out.
but yeah, exactly. But like the thing is, Henry Ford has a great quote. He said, if we listened to the consumer, we would have made a faster horse. And so like you don't need to asking the public if they want AI in business means nothing. Like what you need to say is, do you want to get your order of knickknacks in 1 day instead of 2 days? That's what you actually need to ask them. Because all they hear when you say, do you want AI in your business is basically like, do I want machines replacing me, or do I want like to be a number to someone? But if you ask them what the result of implementing AI will be, and if they want that result, that's what we need to look at. And I think most people would say they want the benefits of AI. And then again, you can flip that with saying, if it means, I don't know, if it means that 100 people in your community will lose their job, do you want to get your knickknacks in 1 day instead of 2? That's a much more relevant question than do you want AI in your business kind of thing.
Yeah, I think that's exactly right. And I think another thing that people who took that survey might be missing is that AI is already here. It's already integrated in business. It's already integrated in our day-to-day lives. The question is where it goes from here. And I think there are really good arguments to say that we should be having a public conversation about that, and that there are questions to be asked about what directions AI should and should not take. But whether or not AI is going to be in business, the cat's out of the bag. AI is here and integrated in business and integrated in our daily lives from the moment you wake up to the moment you go to sleep. And so if you have smart watch or a smartphone that you sleep next to, it's there while you're asleep too.
I was going to say, that's actually a perfect segue to probably like the closing topic here. And this is something that you brought up, JT. It's sort of because most of these algorithms and, per your book, depend on tremendous amounts of data to sort of refine the rule set and to make sure that the outputs are accurate based on the sort of the data that's coming in. So like, how do you balance the amount of data that's needed for a lot of these predictive algorithms, behavioral algorithms, and the waning desire or need for privacy in this world, and the I guess the ability to have some sort of control over what companies and other people know about you?
Yeah, I read today an old quote by the CEO of Sun Microsystems, and he had said that privacy is gone, and in the 21st century, people are just going to have to come to terms with the fact that you're not going to have privacy in the traditional sense.
That's a man after Cody's heart right there.
Yeah, and I think that more and more that's going to be true. In the neighborhood that I live in, I've started seeing the video recording doorbells that are constantly video recording you, and that worries me a little bit, even though I'm not sure why. I think that some of the privacy issues are just they're going to be problems, and we're going to have to make sure that the people who hold the data are accountable for what ends up happening to it. Because you can do it use it to do really nefarious things.
Yeah.
There are oppressive regimes in this world that use data about their citizens to, repress dissenting voices,
exactly,
right?
Yeah.
murder people that they don't like because of their political opinions or commonly their sexual orientation and things like that. And a lot of that, the techniques that they learned come from algorithms that researchers in the United States developed innocently, just showcasing the technology. And that's horrifying, but it's a reality that if you have blind actors with lots of data, we have problems. And so we have to make sure that the people who hold data are safeguarding it well. Because if you have lots of data about people, you can do some really, really bad things with it.
And do you think that's just
exactly?
Go ahead, sorry.
This is exactly our conversation that we had, and I've actually had a little bit of afterthought on this, and I don't think I've changed my opinion, but I do remember something. And basically, what you were saying, JT, is interesting because like it feels icky that there's cameras on you at all times, but you're not sure why. And like exactly what you said is because you assume that someone will do nefarious things with that data. And so data is power. And if that power is not used or used in a benevolent way, it doesn't necessarily lead to oppression. So it's not that this data automatically causes a corrupt state. It makes it easier for a corrupt state to do damage. Now, what I remembered this week was the Stanford prison study, which basically shows that if you give anyone power, they will abuse it eventually, kind of thing. And that's what kind of got me back to rethinking my position where like, can any state, can any nation actually act responsibility in the long term with so much power at their disposal?
That was my whole point. Was I don't think you can I think one necessarily leads to the other. I don't know that you have that much access to that much information without it sort of devolving into some sort of totalitarian system. Not necessarily totalitarian, but some sort of at least a nation of constant surveillance where you're always on your toes about what you're doing, which like, again, maybe isn't the worst. Like it might be the worst, but like, I think that the negative effects of that in terms of the freedom of like, I'm always on the side of like creative voices and like people being outspoken about stuff. The negative effects it would have on that would be so detrimental as to make it necessarily wrong. But it's a tough. I remember you said. I remember you said something like, "We should at least try it out and see what happens," because like you don't know. And your point about us having amendments within our Constitution that protect the freedom of speech and stuff like that, it's such that if we have massive surveillance, we would still retain some of our freedoms. But it's TBD, and once you start, you really can't stop. Is the tricky part. Yeah,
I mean, we're already at a place where technology is dangerous. I mean, you can be targeted for the things that you say on social media platforms.
Yeah.
And it doesn't take that sophisticated of an actor to be able to identify people who have certain traits that don't want to be identified for having those traits, right? So if you're a member of a political organization, even if you're trying to hide it, but I know what other members of your political organization look and sound like on social media, I can probably find you if I'm trying. Not me personally, but someone could, right?
She's looking for you. Watch out.
Yeah.
Let me just ask
Taken. Yeah.
Yeah, right. As we wrap up here, do you think that's the new normal? That people are just going to become more and more, especially like the I guess rising generations, are going to become more comfortable with the entirety of their lives being somewhat accessible and the privacy of their data and their day-to-day lives being minimalized.
Yeah, I mean, the youngest generation self-surveils, right? Because they post their entire lives on Instagram and Snapchat, right? And then they're surprised when there are photos of them everywhere, and Google can recognize their face from outer space.
Right.
And that's I think that someday they'll have to reckon with that. But they're not going to do it when they're in high school.
Right.
Well,
they're not even their brain's not even mature enough to even think about consequences. Like they can't even think about the consequences of like doing shots of vodka in their eyelids. I mean, like they're certainly not thinking about what's going to happen, if they post photos of themselves, but as we were talking, I thought of like kind of a less nefarious example of abuse of power, which is not, it's not really that far flung when you consider the gerrymandering that's going on in politics today. The controlling party could very easily access, get access to things like Ring doorbell videos. And like JT said, they know they can very easily gauge your political affiliation. And again, let's just say I'll create to avoid inflaming anything. I'll just say
like wearing tie-dye T-shirts might put you in the Democratic Party.
I'll say the Whigs and the Libertarians. So like neither of those have any chance of actually being in power. So it's great. We'll use those two parties. So like if the Whigs are in power and they identify me as a libertarian and they know my daily routine and like kind of how I go about doing stuff, they may decide to do like road work in front of my house on the day the polls are open. You know what I mean? Like there are subtle ways if you know someone's behavior.
I thought you were talking about like canvassing neighborhoods and determining whether like a certain neighborhood was good to target, like a get out the vote campaign.
They may even do something less nefarious, right? They may say, free money if you are a libertarian, just come to this faraway location, right? And it's like, now I've got all this free money, I'm going to go buy something, I'm not going to go vote.
Right.
And that, who knows, right? It doesn't have to be outwardly oppressive to be problematic. Yeah.
Well, let's as we sort of wrap up here, let's talk about good uses of your data, and let's one more time talk about your book and the audience for your book. Is it for like would I guess a lay audience get something out of mastering large data sets with Python, or is it going to be more applicable to the technical crowd?
So it's mostly for the technical crowd. I would say it's largely a technical publication. There are a couple case studies in there that I think would be interesting, but I probably wouldn't buy the book if all you want is case studies on algorithms. There are better publications for that. What I would say is if you are a developer and you are looking to get some big data chops, this would be the book that I would recommend.
Will we learn how to keep libertarians away from the polls from your book? Yes or no?
Yeah. Just give them some money and don't tell them what to do.
Perfect. Well, that's going to do it for this week's episode of the Gunner Technology Livestream. Make sure to check out the podcast for this episode on iTunes. The blog post will be available at GunnerTech.com. Ebooks are available on Amazon, iBooks, Kobo, Barnes & Noble, and anywhere else ebooks are sold. Make sure to hop on our Facebook page and enter the Country Store giveaway. Country Store is a lifestyle brand for anyone who loves the outdoors. You can visit them at countrystoreoutfitters.com. And while you're on our Facebook page, answer our question of the week, which this week is, are you afraid of an AI takeover a la iRobot and Eagle Eye? So let us know what you think about that. JT, thanks so much again for joining us for this episode. We really appreciate you hopping on.
Thanks for having me.
And that's going to do it for this episode. Make sure to tune in next Wednesday at 1 p.m. Eastern time for the next episode of the Gunner Technology Livestream. I'm Derry, that's Cody, and that's JT, and we'll catch you next week.